All right, let's record. Everybody say hi, YouTube.
No. Hi.
There you go. All right, what ones on quiz 6 do you want to see? Gotcha. All right. Starting at the top, just like Drake. All right. Find the distance between these 2 points. Well, to find the distance between 2 points isn't that complicated, but it's a little more complicated than a lot of people think. So imagine I've got 2 points, this point here and this point here. The distance is this. Now to find that distance, we're going to pretend this is a right triangle and break it down into 2 different parts, vertical and horizontal. So let's find how far apart these points are horizontally. If I'm looking at them horizontally, I'm talking about their x values. So how far apart is 4 and negative 6? 10. So it looks like they're 10 apart in this direction. And if I'm talking about how far they are apart vertically, I'm talking about their y values. How far apart is 1 and 2? 1. So we've got this, and if we do Pythagorean theorem, we can figure out c, the distance between them. Pythag says a squared plus b squared is c squared, but we won't want c squared, we just want regular c. So if we root it, we'll get regular c. So it looks like we're going to get 101, and that doesn't root nicely. It's a little bit more than 10. There's your distance. That's it. Any questions on that before we go on to 821? Rad. Make sure if you're on your phone, it's because you're working on your portfolio, not just texting people. 821, what is the slope of the line passing through these points? Slope is vertical change over horizontal change. So vertical change, dealing with our y values. How much change between 1 and negative 8, or negative 7? I gave it away. Down 8, right? The negative 8's our vertical change. What about our horizontal change? Our horizontal change has to do with our x values. How much change between negative 2 and 3? Yeah. 5, correct. So it looks like 5 is how much we've got here. So our slope is negative 8/5. Do not write negative 8 comma 5. That's a coordinate, which is a location. Slope is telling us the relationship between x and y. 822. Standard form, which is super easy to graph in. It's kind of like a puzzle. That's how Kaylee Horton thinks about it. Shout out to Kaylee. If x is negative 4, then this becomes negative 12. And if I can make that negative 12 and make this 0, then I win. Well, I can make that 0. If y is 0, the whole thing's 0. So negative 4 is 0 on my line. 1, 2, 3. Finding another point. Another combination that might make this work. Maybe you could plug this in and make that negative 6 and make this negative 6 to get a total of negative 12. That's possible. The way I'm seeing it is that if this is 0, and I can do that by making x 0, 0 times 3 is 0, I can make this negative 12 and I win. What times negative 2 is negative 12? 6 all day. Well, we already got the negative there, so it's, yep. So watch out for that. It's going to be a positive 6. So 1, 2, 3, 4, 5, 6, 0, 6. So there's our line. Beautiful. Pythagorean theorem, distance between the points, vertical and horizontal. Finding the slope, distance between the points, vertical and horizontal. Graphing the equation, finding numbers that make this equation work, right? That's all an equation is, a pattern. And if you can find numbers that obey that pattern, there it is. All you need to do. 841 and 842? Sure. Anybody want to see 832 first? Or 833 on the next page? Kellogg? There we go. 833. Graph this line. It's super quick. Well, we know negative 4, 5's on our line. That's what they're telling us. So 1, 2, 3, 4. 1, 2, 3, 4, 5 is on our line. Cool. And they also tell us the slope of the line is 2/7. Meaning that the slope between any of our points will always be up 2 over 7. So if we want to find another point to make our line, we can use the slope. So vertical change is 2. So vertically I increase by 2. Horizontally I increase by 7. That's 7 to the right. Done. What about 833? Midpoint? Okay. Joey, what did you want to see? Yep, 841, 842. All right, it says find the equation in standard form. Now, finding the equation in general isn't too bad. Getting it in standard form is the thing that takes a little bit more effort. But finding the equation is super easy. I know the slope between my 2 points. I can figure that out really quickly. So, Joseph, how much vertical change between -1 and 3? +4. And a horizontal change of? Well, if we're starting here and going there, it'd be 4, right, for y values. But in reverse, it'd be -4. I don't know. I'm starting here. If I start at -2 and go to 6, what am I doing? Which, of course, we can simplify to a half. So that's our slope for our equation. Now, to find the equation, all we need to do is set this up. We know the slope between any point, that's what x and y stand for, and a point we know, and I'll use this one, 3 for y, 6 for x, will always be a half. There's our equation. Problem is it's not standard form. So standard form has x and y on the same side, and your other numbers on the other. Also doesn't have any division, so let's start getting rid of some division. First thing I'm going to do is times by x minus 6. Now, what is x minus 6? Timesing by that. What is that going to do? What is timesing by x minus 6 going to do? These divide out, and we just get y minus 3. Here I get a half times that. I'll just write that like this. You could distribute the half if you wanted to, but remember, we're not supposed to have division, so how can we get rid of the divides by 2? Times by 2, right? So if I times all the terms by 2, what I end up with is this. That divides out, which is why we did it. And 1 times x minus 6 is just x minus 6. Here we get 2y minus 6. And to get in standard form, we want x and y on the same side. So I'm going to subtract the 2y. Move it over to here. And I'm going to add 6 to both sides. If I add 6 to both sides, you might notice on this side it goes away, because that's why we did it. But also it goes away on this side, so we just get 0. That's okay if you get 0. 0 is a valid answer. And there's our standard form. X, Y, and C. So this one's a little bit weird, right? The setup's kind of strange. First we got to find our slope with our points. After we've got our slope, we can set up the equation. The slope between any of our points and a point we know will always be a half. That's what it's telling us, if that's what the slope is. And then we work to get rid of division. Make it look like that. 842 is actually easier. There's 2 ways to do it. One way is easy, one way is super easy. It says find the equation in standard form. Okay, so again, we're looking for this. And the line goes through 0, 7, and has a slope of -2. So if it has a slope of -2, we get that for free. The slope for our line will be always the distance between a point we don't know and a point we do. So any possible point and the point we do know will always have a slope of -2. And then we kind of solve it the same way. You might notice that x minus 0, if we times by x minus 0 to both sides, it'll get rid of this. But what is x minus 0? It's just x, right? So it might be easier just to times by x to both sides. When we do that, it gets rid of the division in the bottom, which is what we wanted. We just get this. So getting it in standard form, -2x minus y will equal -7. No fractions, so we're good. There's actually an easier way. What's special about 0, 7? What's special about that point? Imagine 0, 7. Where is it on our line, or on our coordinate plane? Where is 0, 7 on the coordinate plane? Not the x, but the up and down one, right? 0 comes, it's on the y-axis. So it's our y-intercept. So that's our y-intercept. Okay. And they gave us our slope, -2. We have a form of a line that just needs those two things, right? Y equals mx plus b. Slope-intercept form. So if we know our slope's -2, and we know our y-intercept is 0, 7, in other words, this is 7 when x is 0, there's our equation. Now we just got to get in standard form. I'll add 2x. Ta-da. So either way works. This one has all negatives. If you got rid of those, it'd look exactly the same. So this one, if you're clever, actually has a really easy setup, right? Just take those values and put them into slope-intercept form. Oh, feeling like crazy. Can I interest you in an 851? It says find the slope, x-intercept, and y-intercept. What form is this? So it gives us slope for free. There's our slope, -3. And it also gives us our y-intercept for free. Our y-intercept, when x is 0, y is 4. That's what this is. Now for our x-intercept, it's a little bit trickier. All x-intercepts have something in common. They're all on the x-axis, right? So they have 0 verticality. So now we got to figure out what happens to x when y is 0. Well, if we do that, we get this. Now riddle me this. What number do I add to 4 to get to 0? What number do I add to 4 to get to 0? Got to be -4. So how do I make this -4? What times -3 gets me -4? 4/3. Right? If I times that by 3, the 3 goes away, and I get -4 plus 4 equals 0. So slope, y-intercept, x-intercept. Since we already have these 2 points, let's just plot them and then draw our line. 4/3 0 is here. And 0, 4 is here. Beautiful. This one's nice because it gives you the slope and the y-intercept for free. Finding the x-intercept ain't too bad, right? Just got to be okay with fractions. What do I times by -3 to get -4? This guy, because the 3's divide out, and I get -4 plus 4 is 0. 852 is similar, except it's not in slope-intercept form. What form do they give us? What form is that? Not slope-intercept. Yeah, good guess. Standard form, right? So for standard form, graphing's really easy. Just plug in some numbers that work, graph it. However, we're supposed to look for our x-intercept and y-intercept. Remember, x-intercepts have 0 for y because they don't have any verticality, right? And y-intercepts have 0 for x because they don't have any horizontalness. So let's just think about that. Imagine that y is 0. What's going to happen here if y is 0, Joseph? What happens when I plug in 0 for y? It'll go away, exactly, right? Because 0 times 7 is 0. What times 2 then gets me 12? Yeah? 6. So 6 and 0 works, and that's our x-intercept. So 6, 0. That's here. 1, 2, 3, 4, 5, 6. For the y-intercept, if x is 0, this will go away, right? 0 times 2 is gone. So the question is, what times 7 gives you 12? 12 sevenths. Because if you times that by 7, the 7's go away and you get 12, and you win. So 12 sevenths is basically 2, but not quite. So if we draw our line, beautiful. There it is. Now we need the slope. This one doesn't give us the slope for free, but it almost does. We've got some options. Option 1 is, imagine we get this in the slope-intercept form. That means y is on its own. In order to get there, I'd subtract 2 x's. So I'd have a -2 next to the x now. And then I'd divide by 7. So there's our slope. Might notice it's very similar to these guys. Another way to think about it is this. I know my slope is down 12 sevenths. And it's to the right 6. This might look really nasty, but it isn't. Imagine you have 12 of something. Forget that they're sevenths for a second. It's just 12 of something. I have 12 things. I divide it by 6. I now have 2, right? 2 things. 2 what? 2 sevenths. These are the same thing. Right? 12 sevenths divided by 6 is just 2 sevenths. And of course, it's negative. So a couple ways to find that slope. Set it up like this and go. That's 852. Can I interest you in 854? I'm sure I can. Slope-intercept form. What form is that? Slope-intercept. What is that?
Y equals mx.
Yeah, it's the one that gives you the slope and the intercept. What intercept? The y-intercept, right? That's what b is. It's okay. So slope-intercept form is what we want to find. Well, they gave us the slope. Okay, cool. So we know that that's going to go here. But they don't give us the y-intercept. They give us the x-intercept. Darn, if they gave us the y-intercept, we just plug in -8 right there and we win, right? But the x-intercept's just a point, meaning that when we plug in -8, 0, it should work with our equation, right? So if we plug in -8 for x, because that's an x value, and we plug in 0 for y, we should get a true statement. Well, that's 32. What number do I add to 32 to make 0? It's got to be a negative, right? Negative what? What number do I add to 32 to get 0? Negative 32, right? So b, in order to make this work, has to be negative 32. So our equation is going to look like this. Done. That's slope-intercept form. It's got a slope of -4, and -8, 0 is on that line because when I plug in -8, I will get 0. That's all the basics for quiz 6. Should we do intermediates or should we go to quiz 5? Doing it for you. It's up to you. All right. Let's start here. Which one's furthest from the origin? So basically what we're doing is we're thinking from 0, 0 to, oh, well, I guess -6 is down. Let's do 6, 6. That'll work. From here to here. What's the distance? Well, we know the distance between points has to do with Pythagorean theorem, right? Joseph, how far is 0 to 6?
Ellie Merrill to the office. Ellie Merrill.
How far is 0 to 6? Do you see how if we always use 0, 0, the distance is just these guys? Right? 0 to 8. -8. It's 8. Who cares about positive or negative? 0 to 5 is 5, right? So, in other words, if we do Pythagorean theorem, we've got 6 squared plus 6 squared. Rooted will get us the distance between them. Well, that looks like 36 and 36, which is 72. So we have root 72 is how far that is. That's slightly more than 8, because root 64 is 8. If I want to check the next ones, what's up?
Hi. Can I do the quiz 5 real quick?
Yeah. Where are you? Ah, got it. There you go. So to find the distance between any of these points in the origin, it's pretty easy. -8's 8 away. 5 is 5 away. So we do Pythag. 64 and 25 is going to get us 89. So that's clearly further away, root 89. 9 and -2, you might think it's going to be further away, but it's not going to be. Because while that's 81, this is only 4. So we're going to get 85 rooted, which is clearly smaller than root 89. Now, -6 will be the same distance, right? Away from the origin as 6, 6 will be. So we already know that doesn't work. 7, -7, on the other hand, is 7 away in both directions. So we get 49, 49, which is 98. Root 98 is clearly further than the rest. So that's our winner. Furthest away from the origin. It's just Pythagorean theorem, which is a lesson you should hold dear, because especially when you go into geometry, everything is Pythagorean theorem. They're learning that now. In fact, they're learning about circles. And circles are just Pythagorean theorem, believe it or not. Ugh. 815. Recall that x, the absolute value of x, is the distance between x and 0 on the number line. And the reason for that is that absolute value just tells you how far something is away. 5 is 5 away, which is why the absolute value of 5 is 5. And negative 5 is also 5 away, which is why the absolute value of negative 5 is 5. So the question is, why is this the distance between x and y? Joseph, I'm on 10, you're on 2. How far are we away? Distance is subtraction, right? So the first reason why we have this is subtraction is distance. And why are we using absolute value? Because distance is always positive. So this implies distance is always positive. That's it. That's why x minus y, absolute value of that is going to get you the distance between x minus y. Because distance is subtraction. Of course, distance always needs to be positive. Doesn't matter where x or y is bigger. It'll come out positive because of absolute value. Might I interest you? An 823. This is one of my favorite questions to ask calculus students because they assume that this is slope-intercept form, and it ain't. You know, slope-intercept form looks like this. That ain't got no x. You know that equations are just patterns. This pattern's really simple. Can you give me all the coordinates where y is negative 7? Joseph, give me a coordinate where y is negative 7. Where y is negative 7. Yep, so 0, negative 7 works. What about 4, negative 7? What about 5, negative 7? What about 6, negative 7? Literally anything negative 7. 0, negative 7 being one of them. 1, 2, 3, 4, 5, 6, 7. Yep. That's 0, negative 7. Here's 1, negative 7. 2, negative 7. 3, negative 7. 4, negative 7. 5, negative. All of these aren't going to go up and down. They're actually going to go left to right. And that makes sense because the negative 7 never changes. The y value never changes. So we're never going to go up or down. The only thing that changes is the x value. 0, negative 7, 1, negative 7, 2, negative 7, blah, 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 blah. It's a weird pattern, but it is a pattern. And that's what that equation represents. So is it a line? Oh, yeah. What's its slope? Well, if you think about it, our slope is literally as much horizontalness as we want. So literally whatever you want for x. And 0 verticality. Well, 0 divided by anything is 0. So our slope is 0. And that makes sense because I think you would agree this line is not steep at all. It has 0 slope. For x equals 1.9, we want all the points where x is 1.9. So 1.9 comma 0, 1.9 comma 1, 1.9 comma 2, 1.9 comma 3. It's a vertical line. The only thing that changes is the y value because x is always 1.9. That's what that means. X is always 1.9. Is it a line? For sure. Is it? What is its slope? Not 0. It's infinite verticality, whatever verticalness you want, but 0 horizontalness. We're dividing by 0 here. That is undefined. For its slope. And yeah, that's it. All the points where y is negative 7. Just think about it for a second. You'll be fine. All the points where x is 1.9. I know I can interest you in 824. Because a lot of you guys are getting very close on this one, but you're getting stuck on one small little thing. So we're supposed to estimate the slope. That's the first thing. So just pick a point that looks sort of like it's a nice point, a nice lattice point. And pick another one that looks like it's a nice lattice point. Looks to me like we're going right 3 and up 2. That's 2/3 slope. Is that really 2/3? No, because I'm estimating it's really like 3 and change. I don't know. But 2/3 is clearly positive. They're both going in positive directions, right and up. 2/3 is less than 1. Don't forget to compare it to 1. If it's positive, compare it to -1 if it's negative. This slope. Is it 0? No, it's undefined. This one, it's hard to tell which line's the line and which one's the x-axis, but it doesn't really matter. Because either way, they're going to have the same slope. The slope will, of course, be 0. For this one, it's definitely negative because we're going down to the right. So down like -2 and then over 2. If that's my slope, and that's an estimate, looks like it's equal to -1. Negative 2 over 2 is 1. For this one, definitely positive. We're going to the right and up. Looks like 1, 2, 3, 4, 5 to the right and 1 up. That's 1/5 of a slope, which makes sense. It's not super steep. And that is less than 1. Here, we're definitely going down, so it's going to be negative. Negative 1 over a bunch. I don't know, like 12, 13, 14. Doesn't really matter. Negative 1 over a really big number is going to have a relationship with negative 1 such that it is closer to 0. So, when we're thinking greater than or less than, negatives can be weird. Imagine a number line. Here's 0. Joseph, where's negative 1 on this number line? To the left of 0. Now the question that really matters, where is negative a 12th on this number line? It is, which means it is greater than negative 1. Like 7, what are we talking about?
If like the 1 was...
If that was a negative 7?
No.
If that was 7/12? If it's positive 7/12, that'd be here. Negative 7/12 would still be here. Ooh, I get what you're saying. So it's not whether it's closer to negative 1 or not that matters. What matters is it greater than or less than? So how do you know 5 is greater than 4? Because 5 is further to the right than 4 is, right? See how this is still further to the right than negative 1?
Yeah.
So it's still technically greater, right? Big is weird. Anything to the right of negative 1 is greater than negative 1. Anything to the left will be smaller, so that would still be negative. If it was negative, like, let's say 13/12, then it would end up right here, wouldn't it? Right? That'd be less than. So that's the part that's kicking everybody's butt. Negative numbers are weird when we talk about greater than or less than. Draw yourself a number line, be sure of it, raise your hand, we'll get it done. Say it again? So what you're talking about is magnitude. So like how far away it is from 0, right? So you would say that like owing someone $100, so negative 100, is more than owing someone 10, right? Now it's still a smaller number because you have less, right? But its magnitude, like vector, direction, and magnitude, you know what I'm talking about here? Oh yeah. So the magnitude is greater. It's further away from 0. How far is it away from 0? 100 versus this only being away from 10. And that's why when we talk about magnitude, we talk about absolute value. So absolutely speaking, negative 100 is greater than negative 10, right? But when we talk about value alone, not absolute value, yeah, it's less than. It does, right? It depends on what you're thinking about. So typically when we talk about value, we don't mean that this is greater than that, right? We mean that's less than. So negatives are weird. Yeah, I understand. Do we want to keep going on intermediates, or do we want to jump to a different quiz? Pause, take a break, relax. It's up to you. Sleep. I have recorded some of these from the other classes, so if you wanted to take a break and then look at these later, you could. 1:41 right now. Still got plenty of time, about 11 minutes. Anything else I can do for you guys before tomorrow, which I won't see you, and then Friday, which I will? Okay?